Dear students, welcome you all for another beautiful presentation. In today's presentation, I am going to explain you another important topic, which is subsequent presentation to our previous video. Actually, by the way, this is lecture number 4. Okay, so in this lecture, I am going to explain you about the dimensional analysis, right? The dimensional analysis. This is very important topic as far as our JEE mains physics is concerned. Dimensional analysis. What is a dimensional analysis? Why it is required? What is the importance of this dimensional analysis? Listen carefully. Dimensional analysis in brief is nothing but so it verifies the correctness. It is used to verify the correctness of the given equation. Very simple. Given equation, because our physics is obviously consists of so many formulas and so many relationships, right? So many relationships. Therefore, sometimes we need to check the equality or the correctness between the given equations, right? So to verify, this is very important. Okay, to verify the correctness of the given equations, the dimensional analysis will be okay, very useful. It is very important tool, or otherwise it is a very fundamental tool that is to be used in order to verify the correctness of the given equation, right? So I will explain you what do you mean by the equation. Okay, so how the correctness will be checked, how the correctness between the given equations will be verified, that we will see with a simple example. Okay, so this is the primary important objective of the dimensional analysis, right? By the way, in our previous presentation, I think we have covered what is a dimension. Okay, in our previous presentations, if you see that, so many important things we have discussed actually. Okay, what are the physical quantities in general? The physical quantities, I just recall in a minute. So, in our previous presentation, if you recall, so under this physical quantities, under these physical quantities, we have seen the first as the fundamental quantities or base quantities, right? You can refer our previous presentation. Fundamental quantities, and then the second one is the derived quantities. I hope you all are remembered. So, derived quantities. In brief, I am writing here. So, the first is the fundamental quantity, and the second one is the derived quantities. Under fundamental quantities, there are basically 7 types are there. We have classified, that is like mass, length, time, and so on. So we have explained there. And similarly, there are certain quantities which are derived from the fundamental quantities or base quantities. Those are called derived quantities. Altogether, they are called as the physical quantities. And with by using these physical quantities, so they will be used in different equations as per the requirement. Okay, these quantities being used to form the respective equations as per the desired uh, requirement, right? So okay, then say for example, so you should know the difference between what is the unit and then what is the dimension. What is the dimension? Like for example, the very fundamental or basic physical quantities. If you say the length, I hope you already remembered this. The length. The length. Length is one of the fundamental quantity. This is one of the fundamental quantity. Okay. It is identified as, okay. So L, L. Okay. And it is measured in meters. Okay. Meters. Meters. That is the length. So meters is the SI unit. Meters is the SI unit. So SI unit, we have seen in last presentation. International System of Units. SI unit is nothing but International System of Units. So meter is the unit for length, right? That is what its unit. Whereas what is it? Dimension. Dimension is nothing but L. The dimension is nothing but L. So for length, so L is the dimension. L is the dimension. Similarly, the another important fundamental quantity or base quantity is mass. What is that? Mass. Mass. So, yes, the first letter itself you can take mass m. M is the dimension of the mass. Okay. However, the mass is nothing but the weight of the any given object. Okay, that is measured in kilograms, kg in SI units. Okay, and SI units, the mass is measured in terms of kgs, kilogram, kilogram. So this is what the unit, kg is the unit of the mass. Whereas what is the dimension? M is the dimension. M is the dimension. Similarly, another important fundamental quantity is the time. What is that? Time. Time. So what is the first letter here? T, capital T, capital T. T is the dimension. T is the dimension. Whereas the time is measured in what? In seconds. In seconds. In seconds. Second is the unit. Unit is the thing in which is being measured. Therefore, in seconds, the time is measured. Therefore, second is the unit actually. Kg is the unit. Meters is the unit. Therefore, these are called units, whereas these are called L, M, T are called as the dimensions. Dimensions. Right? So likewise, we have to remember, like we have to, so you practice some more things based on this, right? So these are what, this is the basic difference between the unit as well as the dimension. Don't confuse. Units are different, dimensions are different, right? Okay. Then dimensional analysis. How the dimensional analysis will be used. So to understand the basic concept of this, let me explain you a simple example so that you will understand very, very better, right? I'm going to explain you a very simple example and please listen carefully. So, which is a simple example which I'm going to solve for you. So, what is that? Verify the correctness, verify the correctness of the equation of the equation. What is that? The equation is given like this. It is half m v square is equal to mgh. This is the given equation. Half mv square is equal to mgh. Verify the correctness. Nothing but what? This is the left hand side. This is the term which is there on the left hand side, LHS, left hand side quantity. This is the term on the right hand side, RHSS quantity. Right hand side quantity is MGH. Left hand side is the, what is that? Half mv square. Otherwise, you already know that. What is this actually? What is mv square, half mv square? Which is nothing but the kinetic energy. K. What is that? Kinetic energy. What is this MCH? This is called the potential energy. Okay, this is called potential energy. Therefore, kinetic energy, half mv square is called as the kinetic energy. Mgh is nothing but the potential energy, and the given equation is kinetic energy is equal to potential energy. That is the given equation. So, whether is it correct or not? Then we have to see for these are the physical quantities. M is the mass, V is the velocity, understood? And again here on the right side, M is the mass again, G is the acceleration due to gravity on the earth. Okay, acceleration due to the gravity on the earth, and H is the height. H is the height. That's it. So I will explain you one by one. So from the for the left hand side quantity, you have to see its dimension. You have to write its dimension. Similarly, on the right hand side quantity, you should write the dimension and you should compare the dimensions on both sides. They must be identical. The dimensions on both sides must be identical for the correctness. That is the condition. Okay. In order to verify the correctness of the given equation, this is the equation, right? So the dimension on left side as well as the dimension of the right side quantity both must be equal, both must be identical. If both are identical, then the given equation is correct, dimensionally correct, otherwise it's not correct, right? Then we will see whether it is correct or not. I will explain you. Okay, I hope you are getting this. Very simple, very very simple, right? In fact, physics is a very beautiful, lovely subject in general, right? Let us see. So, left hand side is the half m v square, and it is right side is the m g h. As I already told you that this is the kinetic energy. Remember, this part is called as kinetic energy, and this is called as your potential energy. This is the given equation, right? So this implies, however, half is the, it is a constant. Okay, half is the constant, therefore there is no unit for that, right? Half is constant. Now this is m. M is the mass actually. M is the mass. What is the dimension of mass? M, capital M, right? Like this, capital M, right? So we should write their dimensions. Remember that we should write their dimensions on left side as well as on the right side. So what is the dimension of the mass? It is m. What is the velocity actually? Well, what is the definition of velocity? You should know the definition of the velocity. Never confuse. Sometimes for simple things we will normally get the confusion. No, velocity I will write here. Velocity. What is velocity actually? It is the delta x by delta t. Velocity nothing but delta x by delta t. What is delta x? That is the displacement. That is the displacement. Nothing but, so say some object is starting from at certain point and it is reached to certain point. The difference delta x is nothing but the difference. The difference in the distance, as well as this is the delta t is the difference in time, right? So this is the displacement, otherwise delta x is the displacement, right? Therefore velocity is equal to what actually, I will write for your better sake. Velocity is nothing but delta x in general, the definition I am writing, and delta x by delta t. That is the definition of velocity. This is the definition of velocity. Now, in general, what is delta x? It is displacement. Displacement is nothing but distance only. Distance. Okay. Distance is measured in what actually? The distance is measured in meters. Okay. Otherwise, length. What is its dimension? Length. It is a length actually. And by, understood, it is the delta x is the displacement. Displacement is nothing but length. What is the dimension of length? L. L. Now, what is delta t? It is the time difference. However, it is time only. What is the dimension of time t? It is L by t. Therefore, for v, L by t is the dimension. Therefore, what is given? Square. Nothing but L by t square. L by t square. Therefore, in combination, if I write like this, therefore, how I can write here? It is nothing but m, okay, m into L by t square. Getting? This implies m. If nothing is 0, you can write m power 0 because, right, the power is 0. Therefore, you can write m power 0 and it is called as L square. Is it not? L square by t square. L square by t square. Or you can write it is m power 0 L square t power minus 2. This t square you can take to the numerator part, then it becomes t power minus 2. Therefore, this is the dimension of your kinetic energy. This is the dimension of your kinetic energy. Therefore, on the left hand side, you will get m power 0, L square, and t power minus 1. Sorry, t power minus 2. Right? This is what the dimension of the kinetic energy which is there on the left hand side. Similarly, you write the dimension of this right hand side part also. Right? So, therefore, I will write here. So, therefore, for the right side, for the left side, what is its dimension? What is its dimension? This implies it is m power 0, it is L square t power minus 2. That is the dimension of the left side. Coming to the right side, just to write, what is m here? Mass. What is the mass? What is the dimension of mass? M only, right? Okay. What is g? G is the acceleration. G is the acceleration due to gravity. What is its value? Look, what is its value? 9.8 meters per second square. Is it not? What is the G value in general? 9.8 into meters per second square. That is the definition. That is the height. H is the height actually. Height. Height is the again distance only. That is nothing but L. L. Therefore, if I convert into dimension, it is M. 9.8 is the constant. Don't worry about constant. What is meter? Meter is the length. L. What is the second square? It is t square. Second square is nothing but the second is nothing but time. Time, what is the dimension of time? T. It is square. Therefore, t square into what is h? Again L. Therefore, m into L into L, L square by t square. Is it not? So, if you again this you can bring this t square to the numerator part, then obviously what you will get? Obviously, what you will get? It is m L into L, L square t power minus 2. Okay, if nothing is there, power m power 0. This is the dimension of your mgh. Now you see that on the dimension of the left hand side quantity, see the dimension of the right hand side quantity, m0 m0, L square L square, t power minus 2 t power minus 2. So dimensions are became identical. Therefore, the given equation is correct equation. The equation is correct equation. This is what the checking of verifying of the correctness of the given equation. Understand? So this is what this kind of this kind of questions will be or can be expected in our JEE main examination, right? So with this, we will stop here. I hope you understood very well this, and in our subsequent presentations, we will do some more examples based on this dimension analysis. Remember that. So definitely, at least one question will be expected from this dimension analysis. Okay, therefore, please go through and practice on your own, right? If any doubts are there, you please comment on the comment box on my channel so that it will be answered, right? So thank you all for watching, listening, and getting motivated. Okay, thank you. We'll meet in the next presentation.